Good afternoon, everyone. This is Sadia Zafar from HRAI. I would like to welcome you to today's session on how we're settling the HVAC debate on ducted versus ductless systems. Our presenters, Sonny Parada from Panasonic and Greg Karwood from Karwood Ontario, will talk to you about their new project that examines the capital and operating costs of a traditional HVAC ducted system versus a ductless air source heat pump installation in a typical single-story home. You will notice on the control panel of your screen the Q&A feature. Please use the Q&A feature to ask your questions at any time during the webinar. They will be addressed at the end of the session. Also note, this webinar is being recorded and the recording will be sent to you following the session. Now we welcome Sonny.
Thank you very much, Sadia. I want to welcome everyone today on the call. Thank you for taking time. If you're in, I guess, the Eastern time zone, it's your lunch. Thank you for attending this webinar, and hopefully you'll find it very informative and interesting. I wanted to start off by I will let Greg introduce himself, and we'll do some project background, but really how this all came about was a phone call from Greg to one of our representatives in Ontario, and he had walked into a home that they were, a job site that they were building one day, and just looked up and saw all these bulkheads and ductwork, and really said, made a call to one of our reps and said, how can we get rid of these, these bulkheads and the ductwork, and then really how can we make a more, comfortable environmentally and more energy efficient space or build of a home. So this is how this all came about, and hopefully you'll find it very informative today. And when we break it down, the energy modeling, the capital costs, the operating costs, and just the benefits of building this way. I will lay out the project and what it entails, but I will hand it over to Greg right now just to give some background on Karwood himself and some of the experience that he has in the building industry. So Greg, if you can do that, that would be great. Thank you.
Thanks, Sonny. Well, like most things in the building industry, all good things come from bad days. Because if you're having good days, you just keep doing what you're doing and what's easy. So a little background on me first. We're a builder out of St. John's, Newfoundland for actually the last 26 years. We started in the mid-90s, doing a lot of energy efficient and accessible homes there. Our typical HVAC or heating and cooling system in Newfoundland was electric baseboard heat and no air conditioning. Lately, with Muskrat Falls coming on and the threat of a lot higher energy bills, we're seeing a pretty good move to heat pump and mini splits. So about 2 years ago, we expanded the company. We moved into the Ontario market. And when we got in Ontario, obviously you don't see much baseboard electric heat, and air conditioning is a little bit more of a necessity than it is in St. John's, Newfoundland. So here, everyone was using natural gas furnaces and electric AC units. That was a bit of a change for us. In the area we're in, there's also a lot of push for energy efficient homes, net zero ready. So the whole natural gas and the furnace is a little bit confusing on that. So I did a bunch of inquiring to our suppliers and trades and real estate agents and whoever of why aren't we using heat pump and mini splits? And I was told, actually more, I was yelled at that no, you can't use electricity in Ontario. Electricity is way too expensive. Gas is way cheaper. No one will ever buy it. End of story. So being a builder, we don't like getting yelled at too much. So I drank the Kool-Aid and I said, this is fine. We'll do what everyone else does. We'll start installing our fully ducted systems with our natural gas furnace and our air conditioning units. And the first thing that struck me was the bulkheads that had to go everywhere. Coming from an area with electric heat and no AC, we don't have bulkheads. If you tried to put one of those in Newfoundland, you'd be tarred and feathered. So just to seeing the level of those that were in Ontario, that was a little bit shocking at first. But like everyone else, we just sucked it up and learned to live with it. So that's a little bit of an introduction of sort of how we got here and what we were doing.
Perfect. Thanks, Greg. So what I'd like to do right now is really just lay out the project, and you can see on the screen right now, we really are comparing two identical homes. These two homes are being built in St. Thomas, Ontario. So keep that in mind while as we're going through this. And we're calling it the traditional ducted home against the Panasonic ductless home. And that's what we're calling it today. So if we get into it, what we'll see here is really, I'll kind of get into the scope of the project, equipment design, and also kind of some of the reasons why we want to build on the right side of the Panasonic ductless home. But I think you might have touched on this, Greg, already, but really, I think this is the screen or the shot where when you walked into that home and you were able to kind of look at it and say, why are we building like this? And it was that kind of bad day. If you can just explain that quickly before I go into the scope and the design of the project.
So this really boring slide is where all this started. So this house was under construction, and after having so many houses with the ductwork just being willy-nilly all over the place, there seems to be a competition in Ontario that I don't understand, of who can put the most bulkheads in the worst possible locations in every single house. So in our latest iterations of design, and we're a design build firm, we do commercial and we do residential. So we have our own designers and architects in-house. So we spend a lot of time on this plan to try to figure out where all the ducts were going, to try to keep it out of the larger rooms. And we had everyone in on that. We had our designers, we had our HVAC contractors, we had our site guys. And basically in this house, we tried to put all the ducts against an exterior wall, all our big bulkhead ones, to try to keep the middle of this big great room open. So one Saturday afternoon, I was doing a drive-by and I seen our HVAC contractor's van out front. So I figured I'd drop into the house. So when I got there, I figured everything's going to be okay on this. We spent so much time, we laid it all out. We had it on the drawing where everything was going to go. So we're all going to get good, right? Not a chance. Walked into the house, bulkheads were right where Sonny's cursor is there now, right down the middle of the room. And not only down the middle of the room, they got halfway down, they turned north and went out through the exterior wall. So not only did I have a bulkhead right down the center wall of the room where I didn't want it, it actually cut the room in half with a bunch of bulkheads. And then the door is not shown, but there's actually a door in the mechanical room right next to where the bathroom is. The HRV was actually hung right in the middle of the door. Not back against the exterior wall or anything, right in the door. So when you open the door, you had to duck under the HRV to actually get into the mechanical room. Made no sense whatsoever. So that was one of those last straw days for me. I had a little tantrum. I went upstairs and I called Brian and said, there has to be a better way to do this than all these bulkheads. They keep telling me that we can't do, electric heat pumps and mini splits, but I don't believe them. So what can we do? How can you help me here?
Perfect. Thank you, Greg. And that's what leads us into this. So we'll get a little bit into when we had that screen showing the two homes, the traditionally ducted versus the Panasonic ductless home. This gives you a little snapshot of basically the equipment and the design and the technologies that are involved in both of the homes that we'll be comparing and monitoring after this build. So just traditionally ducted home, you got your gas furnace, your air conditioner, condensing unit outside, your gas water heater, your HRV. Very typical way builders build homes in Ontario. I live in one. Most of the people I know live in one that have this set up. So we said, how can we really look at a more energy efficient, a more comfortable, and I think there's a huge play in the environmentally friendly, or if you want to call it, fossil fuel free or carbon free, and really how can we, we know now, and we're living today. I don't think in the last several weeks with whether it's, forest fires and the heat that's kind of come our way. I think if you think climate change is not a thing, then you have an issue, because right now it's front and center. And we said, how can we help achieve our goals? And everybody's saying now we're not going to be able to achieve it by 2030. So how can we start doing things now today to affect the change when, for example, my kids and my grandchildren are able, need to live comfortably and in a safe space. So presenting the Panasonic ductless home. And when we look at the technologies in here, I really want to stress, I don't want to spend too much time on the technical side of it, but really what we have here is we have a total indoor air quality solution. And I know we've mentioned the heating and cooling, but you'll see as we go through this, we've really thought this out well. And it really does start with a cold climate multi-zone heat pump, right? And we do have, I think there's 4 or 5 zones. I'm not sure what I think it's 5 zones, but we have some 12,000 BTU for some of the bigger spaces in terms of an indoor head, and a 5,000 BTUs for the bedrooms. And keep in mind, I know I didn't go over this yet, but these are approximately 2,500 square foot homes, 2 bedrooms, 2 baths, pretty simple design when you talk about a home, obviously very tightly built. So you'll see when we go through the modeling in terms of heating loads and cooling loads, there's not a whole, they're not like as big as you would when you need to, when you don't build a house that's tight. But mini split heat pump that takes care of your heating and cooling. And then we have an ERV as opposed to an HRV in the traditionally ducted home. That's our IntelliBalance 100. And then we kind of found this interesting as we were discussing how we could make this design and compare it, is we have a ventilation fan that has a heater on it. So we call it our Whisper Warm. Very quiet fan, still has the exhausting, obviously benefits, but also has some backup heat. So those going in the bathrooms provides a little bit of backup heat and additional comfort within those bathrooms. One thing that is exclusive to Panasonic is our Swidget control. So when we talk about a healthy, a safe, energy efficient space, we now can tie in the smart space, right? And that's really key. It's more of I won't get into it too much, but it's more of a set it and forget it around your ventilation and your indoor air quality strategy. And then there's a heat pump hot water heater that's not Panasonic, but we really wanted to make this kind of your all electric as opposed to your, your gas water heater and your gas furnace and then your HRV. So that kind of lays out the design between the two homes that we're going to compare. And keep in mind too, that we're not only going to build these, but we are going to, and Greg will touch on this a bit. The key is that we're going to monitor these. We've done the modeling, and modeling is great because you can use specifications and you punch in the numbers and it spits out, whatever it spits out. But we really want to prove our point by doing the monitoring, and we will be updating, the Canada or the world or the industry on how that's going compared to what we show you today. So just some stuff, increased comfort at a reduced cost. When we talk about, maximum comfort, and we talk about zoning with the ductless heat pump and with no ducts and having a wall mount in, strategically placed out throughout the house, a bunch of them, you do get your increased comfort, your lower operating costs already. We know that the heat pump today, mini split heat pump, has technology in it like inverter compressor technology and a lot of other things that really make it an efficient, intelligent unit that really does cut down your costs when you look at heat and cooling. So, and then
on that point there, before you move on to that one, Sonny, the room by room was a really big one for me. Not coming from an area that deals with ducted systems. In the wintertime when it's cold, the entire outside of your house is the same temperature cold. So we have to balance our ducting system. So we're providing cool air, or sorry, warm air to all the exterior rooms at about the same level. In the summertime, you have a warm side of your house and you have a cold side of your house, and that changes throughout the times of the day. So if I have my ducted system set up to work well in the winter, we were having comfort issues in the summer because we were putting the same amount of cool air in all the rooms. So some of the rooms were too warm, some were too cold. I'm sure lots of people who have these type of systems with 2-story houses, their basement is freezing, their main floor is so-so, and their top floor can get overheated in the summer. So you're cooling it way more than you need to on 2 floors, so you're burning a lot more energy than you need. The system that Sonny designed for me with room by room controls Wintertime, I can have even amount of heat again in all the rooms. In the summertime, I can have some rooms that are cool more than others. I can cool my upstairs in the nighttime when I'm sleeping, but not so much during the day. So the room by room control from a builder and customer satisfaction point of view, that was a really big deal for me. So I really liked the way they had that set up with the non-ducted, and I could have a room control. Sorry, Sonny.
Yeah, no problem. No problem. Great. And I mean, I think, I think the question is obviously comfort is really big on people's mind. If you're not comfortable, it doesn't matter how much you're spending. At the same time, if you're not comfortable, then you're not happy. I think what we have here is we've found a way really to provide maximum comfort at the least energy wasted and still being really environmentally friendly. So just touching on that, when we talk about IAQ solutions and really tying the whole, what you see on, we see the ERV on the right side with the mini split, the smart controls, the whisper warm. And really what we have here is we have flexible solutions, and we are really one of the only manufacturers that can provide that total indoor air quality solution. And, that's not why we're doing this project here. We're really trying to show, can we reduce fossil fuels? Can we start doing that today? And is it, can builders start building this way and feel confident that, they'll have a home at the end of the day that the homeowner moves into that they're happy with what they're spending, what they're comfortable, and, in a peace of mind of contributing to the greater good of our environmental goals. So that's really what we got here. And what we'll get into now is Greg will kind of get into the energy modeling part and really comparing the two designs. And then this is kind of the meat of the presentation that if you haven't been paying attention up until now, this is kind of where it kicks in, and you really want to start looking at this and enjoy. Go ahead, Greg.
So I knew the biggest resistance I was going to get was around cost, and no one believes a builder no matter what they do anyway. So I wanted someone independent to look at the two systems. So I had my existing package that I was building in this particular home, and 4 houses down the street, I have the exact same model going up. So I got the design that Sonny showed you earlier from Panasonic of what their system would look like. So I went to Building Knowledge. They do a lot of our energy modeling and whatnot. And I said, all right, I just want to compare these two systems from a heating point of view. So forget the user impacts and whatnot. Just let's look at the heating, cooling, and hot water in them. Let's assume it's a standard built house. So it's not a net zero house. It's not a net zero ready. It's the standard performance house that we would build. Just look at changing the equipment out, what difference that would make. And I wanted to take the energy modeling and the cost over a period of time. So the only thing that I changed in the future years is I didn't assume there was any increase in the price of gas, any increase in the price of electricity. The only thing that we put into the costing model was the increase in the carbon tax, which we know is coming. We assume that gas and electricity is probably going to raise at about the same rate. So we just kept it at today's rate. So I firmly believe right from day one when I went to Ontario that the electric system would be at least as cheap as the gas-fired systems right from day one. So when I sent this to the Building Knowledge to get a modeling done, I was actually surprised to find out that it's not only as cheap, it's actually cheaper to put in the electric mini splits from an operations point of view than it is to use a gas furnace with an air conditioner. That was even a little bit of a surprise to me, and it definitely would be to all our homeowners that we're dealing with. So you want to just flip to the next slide there, Sonny? So we looked at a 20-year time span. So as Sonny said, we have no gas in the test house at all, and we have a gas water heater and a gas furnace in the existing or the normal house with an electric air conditioner. So right from day one, we're about $100 a year in savings just straight up savings for the homeowner in their operating costs with this system that Sunny designed for me. So the big negative that I had from a resistance point of view was it's going to cost too much to operate. Right out of the gate, it's actually cheaper to operate. And if you look at over 20 years with just the carbon tax increases in, it can get pretty significant. This is $7,000 savings over 20 years, and that starts to add up. Let's go to the next slide there, Sonny. So there's obviously other reasons why I did this. My bad day had nothing to do with my homeowners spending more or less for energy. My bad day had to do with all kinds of ductwork going anywhere. So from a builder point of view, what does it mean for cost for me? So when I looked at a whole bunch of different things that change between the two systems, so I got to install the two systems. So there's the mechanical equipment cost to physically buy the equipment. With the ducted system, I got to install bulkheads, and you got to drywall, you got to tape them, you got to lay them out, you got to get approval from homeowners and all those things. So any builder or HVAC contractor in the room is going to know what they are. You had to paint those. You had to paint those bulkheads, so that's another cost we had. Then we got into some of the schedule things. All builders that are going to have slightly different, but we found it was about a 3 to 5 day difference in our schedule between the ducted mini splits or the ductless mini splits and the ducted furnace and air conditioner. We also have to deal with exterior penetrations. So I come from Newfoundland, and it rains up there, and we're kind of sensitive about anything that goes to an exterior wall. So we just don't poke things out through and just tape around them. We actually do a really good job of trying to seal those up, which gets costly. So every hole we have in the wall, it's another hole we have to deal with. So that started to add up for us. The ducted system we were using, it was just a standard ducted system. So we had a floor register for the heating, cooling, and the return airs were in our walls. So even though our company has a cover that goes in the floor just as the ductwork is installed, like the competition on who can get the most ductwork, it seems to be the competition on who can take these covers off and sweep the most dirt down into the ducts during construction. So before closing, we got to clean all the ducts out and take the construction debris out of them. So there's a cost with that. When you have ducted systems, every time you frame a house, even if it's the exact same house, it gets framed slightly differently. There's joists cut off, there's ducts cut, there's holes all over the place. You have back framing that you have to do. So again, cost with that. With a ductless system, you don't need a duct layout meeting to show someone that there's a great big duct right in the middle of our living room. We're planned on hanging artwork, so you don't have those meetings you got to have. And the design meetings for laying out all those bulkheads we didn't have. So looking at the particular house we have here, whether you have a finished basement or unfinished basement, there's a bit of a difference because this is a 1-story house. It gets a little bit different with a 2-story. But for an unfinished basement, it was about a $2,000 to $4,000 savings. For a finished basement, it was a $5,000 to $7,000 savings. So costing number 2, does it save the builder money? Yep. Okay, so it saves the homeowner money and it saves the builder money. So why are we not doing this? And that's when Sonny and I got together and said, all right, we need to pull the trigger on this because it makes no sense to not do anything else. And it was funny, this is the second time we've done this presentation. And the day before we did the first one, I took all my project coordinators and project managers, and they did just a small course with Panasonic just to show what these systems are and how they worked. And I think it was more of an installer course. It wasn't even really suited to us, just to give them an idea what these systems were. And when I walked back into my office, my project manager was standing at the door waiting for me. And I said, we got to go to Mississauga. We got to go see this. I said, we're not installing any more furnaces again. This is foolishness. This is the only thing we're ever going to install again. That was an 1.5-hour course that he had. I wasn't expecting that kind of impact, but whoever taught that course did a really good job. Do you want to switch to the next slide there, Sonny? So that was the 2 hard costs. The benefits. Then we got into a whole bunch of the softer benefits that this brings. As I mentioned in our introduction, or sort of blew by quickly, that we were involved in the R2000 program back in the 90s. So our company has always been involved in leading edge energy efficient things. And I'm also from Newfoundland. So if you're from Newfoundland or Saskatchewan or Alberta, you're very much in tune with the oil industry, and it does a lot for our economy. So we kind of take it a little bit personally when we're being told you have to stop producing oil, which is where all our income comes from, when you have the big middle of the country with a natural gas pipeline going into a new subdivision every single day. It makes no sense that we're still, using oil and gas, but we're not allowed to produce it. So from some of the soft things, Sonny mentions the fires and the global warming and whatnot. So in our last Newfoundland budget, we actually have a grant program now of $2,500 that'll go to a homeowner if they want to take an oil furnace out of a house. We have oil, not natural gas. Take an oil furnace out and replace it with an electric system. Which, fine if that's what you want to do, and you want to try to get people to move more towards the energy efficient electrical systems, but we're still allowed to install oil furnaces. So you're allowed to install a new one today, but they'll give you $2,500 to take it out, which makes no sense. We're doing the same thing in Ontario right now. We know that by 2050, if we're going to be at net zero emissions, we're not going to be able to use natural gas in our houses. So all these natural gas furnaces that we're installing now are going to have to come out. So why are we still installing them today when we know that in 25 to 30 years, they're all going to have to come out again, especially seeing this is not new technology. We can do it today. It actually saves money today. So why are we still installing the old ones? So for our environmental mandate, this system, this suited where our company definitely wanted to go. Mentioned before, there's no more bulkheads, and no more gas lines into the house at all. One of the developers we're working with now is actually looking at doing a subdivision and not putting any gas lines in the subdivision whatsoever. So the whole subdivision don't have the gas lines to deal with. So 3 to 6 days building schedule savings. We touched on that. The penetrations we did, the cheaper to install, back framing. The room by room control, I touched on that a little bit earlier. That also has a cost implication of overheating and overcooling the different areas of your house. If to be comfortable, you have to turn the system up higher. So there's areas of your house you're cooling 2 or 3 degrees more, or 4 or 5 degrees more, in order to get comfort in far reaches of your house. That all costs money. It all costs energy. Comfort in all rooms all the time. That's sort of part and parcel with that. The other one is a quiet operation. The system that Sonny has is super quiet. I know some of the air conditioners we're installing, whether you're in the house or out of the house, they're very noisy. Some of the gear that Sonny has showed me, I've been standing next to it when it's on, and I have my hand on it to actually tell that it's on. I don't believe him that it's operating. It's so quiet. And the last one that I had here, we touched earlier. The customer actually has lower operating cost. So you get a lower cost to the builder, lower cost to the homeowner, meeting our environmental mandate, not hacking the house up with bulkheads. It's faster. To me, when we actually put this together, it was an absolute no-brainer that this is the way we're going to be moving, not just for our pilot project, but for all our houses. I know you got skeptics out there saying, yeah, that was just a theoretical energy modeling you did on the house. And absolutely true. I'm a skeptic as well. So we're actually going to have building knowledge monitor these 2 houses, which are on the same street, same facing direction, everything, for 2 years to make sure that the energy model that we had actually matched what it's being used in the house. We're not going to model the total energy in the house, just the heating systems. So we'll actually be able to verify that what that modeling was is the actual savings that we're getting.
Perfect.
Pretty well, Sonny?
Yeah, I think, and that's what we have to, I just want to reiterate again that, of course, this is a pilot project, and yes, you know, you can put things, you can get specifications and you can get certain things out of spec sheets and put them into a model. And, you know, are they accurate? They can be pretty accurate. I mean, that's how we kind of, I think that's how builders kind of build today and design their homes, depending on, you know, which way they're building. But I think we really have to stress the fact that, I mean, we can make a difference today. And you know, just in terms of contributing to helping out the environment, and I don't think it's as more important as today. I mean, I just turn on the TV. I'm in Winnipeg today and had a meeting yesterday, and basically the first thing that came out was, you're lucky you were here today and not yesterday, because you couldn't see a thing in the sky because there was fires. I mean, there's all these things that are happening that are contributing to climate change that, you know, how can we make a difference? And I think as Panasonic, I mean, that's one of our goals globally, right, to contribute to society. And I think the environment is probably, you know, top of that list. But I think that with Greg and his, you know, his bad day story really turned this into kind of it is what it is, guys. It's a pilot project. And I think there's going to be, you know, people that are on this call that, you know, if they eventually see what this is, that'll have an opportunity to kind of cut it up and figure, you know, well, why are you doing it this way and not that way? And really what this is just kind of a first crack at, you know what, we have two homes that are the same, and we really want to look at how we can affect that change. And you know what? Yes, environmentally, comfort, energy efficiency. I mean, these are all things that are talked about when builders are planning and building new homes and communities and, you know, multifamily buildings, whatever you want to say. So I think the fact that we'll be able to monitor this and get some true data, because I think that the data is king. And then we can really, you know, within a year or two. And I think what we'll do is we'll keep the industry updated. We haven't decided, you know, how often, but really we want to know that it's, you know, what the modeling says is true. And by monitoring these two houses, we'll get some good data, and we'll be able to tweak, you know, we might have to tweak the design, but this is what we're starting with. So it's really, you know, keep that in mind. It's in St. Thomas, Ontario. Keep in mind the, you know, the design temperature, all things, because there's going to be questions that'll come up, you know, whether it's around ductless air source heat pumps or whether it's a ERV as opposed to an HRV. But what I really wanted to stress is that, you know, we're trying to help builders and give them a total indoor air quality solution that kind of handles the heating, the ventilation, the air conditioning. And then, like I said, when we talk about IAQ and really increasing the indoor air quality in a space and then making it an intelligent way to do it, we really are one of the only ones out there that can do it. And I'm really glad to collaborate with Greg from Karwood on this, because it's, you know, we kind of are on the same page, and hopefully we can prove what we're saying, but that'll be to be determined. And that's where we get the stay tuned for more. One thing I will say too, we're kind of getting to the end and we'll have some questions. When we talk about Panasonic and the total indoor air quality solution, I would say stay tuned for in the next, you know, probably couple months, we'll be launching an indoor air quality campaign called Panasonic Breathe Well. And that's really all I have to say about that. Just stay tuned. There's some exciting stuff coming around how Panasonic can provide a total indoor air quality solution. And if you have any questions or want to learn more about it, please contact me. Please feel free to contact Greg if there's any questions after this call that we might not get to today. But I think, Sadia, I'm not sure if there's any questions, but I think we've kind of probably finished a little bit early. But if there are any questions, let's take them now and we'll go from there.
Hi, Sony. Yes, we do have a couple of questions. One of the questions came up when you were talking about zoning. So the question is, it sounds like forced air zoning.
The typical system we were using was a forced air system, yes. The system from Panasonic was a ductless mini split system.
Yeah,
Okay.
so I think, yeah, when we talk about the traditional home with the gas furnace and the air conditioner, there was no, I mean, you can get into zoning on that sort of solution where now, I mean, we're talking a whole different level of cost in terms of, the zoning capabilities and what that'll cost. But really, it's your traditional ducted system, gas furnace. You have your ducts going to each room, your registers, wherever they are, providing the heating and cooling, whether it's in the summer or the winter sort of thing. So, and then comparing it to a mini split ducted multi-zone cold climate system with indoor wall mounts, like you saw earlier when we showed the technology and the products. The wall mount hung unit that a lot of people might say is ugly, but really, I think in terms of us here in Canada in general, we're probably the least behind the world in the way we heat and cool. And if you have traveled the world, you'll see those wall hung units pretty much everywhere and anywhere. So.
Okay, thank you. Another question is, how will you get humidity in the winter and fresh air? What will be the cost for service and maintenance on all items that will be installed in the home?
Want me to take that, Greg?
So typical to your simple ERV systems, there are filters and stuff that have to be cleaned in these units. From what we've looked at so far, the maintenance cost is going to be about the same, whether it's a ducted system or not. We don't have ducts to clean, but we do have filters in each of the heads, so there's more filters that actually had to be cleaned. It's fairly simple. We have some in one of our apartment buildings in St. John's right now, and we basically train one of our own employees to go do those simple maintenance things. So there wasn't a big difference in the cost on the two of those.
Yeah, and I'll add a little bit to that. I mean, I think it's minimal on that side of things. I mean, with your forced air furnace, you have your whether it's your 3 months or every season or every 6 months, you have your filter change. There are some sort of, spring and fall inspections, whether you're getting ready for cooling or your heating, that can also be applied. It's really just a matter of, a lot of times it's the contractor that's, that you have to take care of your system in your home. And, do they provide maintenance agreements? And should you be looking at, getting some gauges on there twice a year, once a year, just to check stuff out. But it really is low maintenance. But there is, like Greg said, that filter change, wash it out, put it back in, very easy. You might need a stool. Very user friendly that way. And then there was a humidity, I think, question. So this is the HRV versus ERV question. So Panasonic is in the ERV business. We've never manufactured an HRV, and there are some differences. And keep in mind, the ERV system will be ducted. And I know we're trying to get rid of ducts, but that's a whole different ball game. You can put that ducting, and you can hide it in places and put it in places where you can't hide the forced air ducting. But with the ERV, we have the ability to really look at the full year heating and cooling season, and be able to have that moisture management all year round. So, and when I talk about the smart controls with the switcher controls that we're able to apply to those, it really does kind of have a set it and forget it scenario where, you basically tell the control what you want your space to be. So typically 35% to 60% is kind of your range where, bacteria, virus, mold, all that nasty stuff, right? Those pollutants thrive, but you can tell it how you want it based on, sometimes somebody will have a health issue, but it's one of those things where we have the solutions to, not only the controls, but the actual equipment to make sure that we're managing the humidity, which right now, being still unfortunately in a global pandemic, but just indoor air quality is such a front of mind, and the peace of mind of really being able to live, because you're spending more time in your house. I mean, hopefully we can start getting out more as we get through this, but that safe, healthy, smart space is what we're trying to create when we talk about the Panasonic total indoor air quality solution.
Okay, perfect. We have another question. Greg, it looks like you are typing an answer to that. Did you want to take it live?
Sure.
It's regarding resistance. Is there resistance from the dealer network to install these systems?
Not really. Most of the HVAC contractors we're dealing with do both. So it was really no difference to them whether they installed the ductless system from Panasonic or a ducted system with a regular setup. So I didn't have anyone say that they didn't want to do it at all, and actually it was met with a pretty good response, because from their end they're saving a bit of time too. So with how busy things are in this market, anything that can save time for everyone was actually looked at favorably.
Yeah, and I think I'll add just a little bit to that, because I've been pretty involved on the dealer side of it. When we talk about, let's take Ontario, for example, and of course, that's where I'm from and I've had most of my dealings. But when we look at Ontario specifically, there's a whole whack of HVAC contractors, and most of them traditionally have been installing and building systems with, the traditional home that we have here that we're comparing with the gas furnace and the air conditioner. And I think what they're finding now, obviously we're talking about this as kind of a whole home solution, but the ductless heat pump has come a long way and is also now used for, whether it's an addition to a home or a sunroom, or adding cooling to a spot, or, a mini split in the garage. I mean, when you name all the options, I think more contractors, and I'm saying in Ontario specifically, because a lot other parts of Canada have already adopted that, are becoming more aware that, they need to have more certified installers of ductless heat pumps, because there's more of an ask for it, right? Take the cooling, for example. I'll take BC. Cooling is not something that really gets designed into like, say, we'll take Vancouver, for example. But now the heat wave we had, and I mean, the climate change is taking the effect. The heat waves that we've had over the summer that have really killed more people than ever. Their air conditioning is not a luxury anymore. It's pretty much a necessity. So how do you introduce air conditioning into a system that's already, say, forced air? You know what? You have to put a mini split or a ductless heat pump, however you want to look at it. That's a great way to introduce air conditioning, unless you're going to put a window shaker or kind of a portable one, which really you're wasting your time and your money. So as a country and across the country, all our installers are becoming more aware that they need to adjust and be able to take on that, because the air source heat pump is not going away. The mini split's not going away. And it's really going to be the way that we heat cool our spaces moving forward, and it's going to help us reach our goals.
Perfect, thank you. The next question is in regards to the temperature. It's they ask, will the heat pump be able to handle up to -25 to -40 degrees Fahrenheit?
So our design temperature for this region was -26, so that's no problem. Once you get into -40, the way we had the system designed, it would have to be redesigned for a -40. You would probably have to have a bit of a backup heating system in it, more like a traditional heat pump than the mini splits. But up to -25, that we were fine with that, and didn't need any backup heat for that at all.
Yeah, and I'll add to that too, because I think I really wanted to stress that this was in St. Thomas, and the design temperature, because I think there's in the market, we talk about -40, -30, -25. I mean, these all get thrown around. And yes, is a heat pump, I'm in Winnipeg right now, in a hotel room, and Winnipeg you get the -40s, more than you'll get in a lot of other places. Is the ductless heat pump your first and your primary source of heating in this market? Well, it could be with certain designs, but is it really? I mean, probably not. But when we get to those areas where the design temperature is closer to -20, -26, I mean, you can even say -30. And the key with these heat pumps, and I mean, I'll talk for ours in particular, is yes, they're rated -26, right? But the point is that they will still go if it's -30, -35, and I have data to prove it. They're still going to provide the heat. They're not going to shut off. Now, will they be less efficient? That's pretty much anybody's heat pump in the market will derate. So you got to be careful on where you are, where you're building, what design temperatures you're designing to, and be wary of that. And this is why we're doing this, guys, is to test these two things. And really, to test the projects, test the two systems and the designs, and really say, hey, you know what, maybe we need to tweak it this, because even in a minus 26 or minus 25 design temperature, we might have to add this or that. And that's why we're doing this, right? So this is for builders. This is a new thing for us. This is a new thing to, you know, really, we're a lot in the retrofit and replacement market. Building with these types of units and with this design is fairly new, and builders will look at it and say, I need to know more. And that's why we want to start this now rather than wait, you know, a few years or 5 years and then start it. Let's get the information that can now help us design a certain way that's going to, again, I'll say it, make it more energy efficient, make it more comfortable, and really help us environmentally and get to our goals. So
perfect. The next one's more of a comment than a question. They say this allows additional savings of up to $2,000 compared to traditional forced air zoning. Very nice. I'm not sure if you want to add more to that, but it's more of a comment.
No, I think we covered that off pretty good.
Okay, next question. In a large building, you might need more than 5 zones. Would this require more than one outdoor unit?
Yes, we can get a fair bit larger home than, because it's a very small home, as you've seen by the drawing, without going with the second unit. But as the home gets bigger, we would need to have a second outdoor unit.
Perfect, thank you. And we have, how does the HRV, ERV service the whole home without ducting?
It actually does. Sonny touched on this a little bit there earlier. It actually does have ducting, but the ducting is very small, and we're able to actually put that right in wall cavities and within our existing floor joist structure. So we don't actually have to have bulkheads for that, or just because of the size of it. It's the really big ducts that we were having the issues with for the heating and cooling. So you will have to get some of the piping through. It's just a whole lot easier to design that to get it in a wall and keep it in a wall.
So I guess that next question sort of, because it's related to bulkheads, it says the ventilation system still needs bulkheads. What do you do for the ventilation system?
Yeah, when I did the introduction there, we have electric heat systems in Newfoundland we've been doing for years. They do have HRVs. We don't see too many ERVs there. And the ducts have always been small enough that we've been able to design the house to take the small ducts without actually having to have bulkheads.
yeah, and also when we talk about, I just wanted to keep, because this kind of, we talk about, you know, when we talk about heat pumps, we talk about cold climate. It's important to note that our ERVs are cold climate down rated to minus 30 in the specification. So we kind of cover that both, because that's an important thing. And I mean, an ERV, if you don't know, as opposed to an HRV, not that it's a big deal with ducting, but it's there's no condensate in an ERV. So there's a few different advantages. Like I said, we're able to recover the heating in the winter and the cooling in the summer. So that's kind of your all year round moisture management. But guys, like I said, we're working on this design, and the whole goal is to, you know, look at it, monitor it, and tweak it so that we think it's the most energy efficient, most comfortable, and most environmentally friendly solution that we can put forth.
Another question, how can extra humidity be added for the winter, disregarding the ERV control aspect?
Extra humidity added?
Yeah, a lot of the houses that we monitor in the wintertime, they do get down on the low end of the humidity side. We haven't really gotten into adding extra humidity as a builder, but we are recognizing that they're getting down, especially as we're really tightening these houses up. Seniors housing, especially, where you're not taking showers that often, you don't have a lot of dishwashing, they really get down on the low side. So something we really haven't looked at doing, adding extra water into our designs, but it's one of the things we're actually looking at.
Okay, then we have a comment. It says heat pumps don't dry out the air like a furnace would. It's a comment.
I agree with that comment. I I have a heat pump in my house and it's great. I've been in houses with forced air furnaces and I don't like the air that comes out of them. So Keith and I agree on that one. Interesting question there from Jeff on the tankless water heater versus the heat pump. Yes, it does put a little bit of extra capacity on the unit itself, which had to be factored into our design calculations from building knowledge. Kind of a debate that I haven't 100% settled there yet. The electric tankless need a lot of energy, so it's a big breaker with them. So I went this route in this pilot because I didn't want to have a big electrical panel in them either. I want to try to keep the electrical load or electrical panel size as low as we could. That's something that I was going to look at in the future ones, is whether it's actually better to use the electric tankless for energy efficiency. Probably is, but I haven't actually got all the data back on that one yet. I also like the electric tankless in that they're super small, the same as the gas tankless ones. So they just fit on the wall. They don't take up a lot of space, and then you don't have the issues with the heat pump taking the heat out of the air and whatnot. So yes, that is something that I'm looking at as a future project to see which one of those actually is the best way to go.
Okay, last question. Can the heat pump have simultaneous heating and cooling operation of indoor units?
That one's on you, Sonny.
Yeah, simultaneous. Well, remember we talked about room by room control. So we're not talking about a 3-pipe like kind of VRF system here. There's a different technology where simultaneously, but in true, I mean, you have your zone, you have your control of each unit, that wherever you have that indoor unit. So you're able to control that space, but you won't be able to, I mean, you can have one, essentially you're going to have one that can heat in one room and cool, but not all. You won't be able to control it from one main controller.
One more question popped up. Are there any common issues with retrofits?
I've done some renovations with these. I actually like them in a retrofit situation because you actually I'm doing a renovation on one of my homes in Deer Lake right now, and I'm actually going with the mini splits because I don't want to tear the place apart to get it in there. We just got the 1.5 inch lines to come in. The unit just bolts on the wall on the outside. So it actually allowed me to get a heat pump system in there without totally destroying the place, because I wasn't doing a full interior reno. I was more doing an energy reno. So I actually really like them for that, just because of the low amount of tear up.
Okay, then we just have another comment in the chat. It says, we've been doing this for years in Vancouver Island. It takes time to training contractors and builders. Only issues are cold climates like Alberta.
Right. And like I said before, guys, it's really, I mean, there's a reason why, you know, in Alberta and those northern parts where, you know, a mini split heat pump, there's probably I don't want to say a better alternative, but an alternative to heat in those certain design temperature requirements. So, I mean, has the heat pump come a long way in terms of being able to, you know, take those cold climate temperatures? Yes, but you still have to be wary of where you are, where you live, where you're designing, and what solution you're putting in. And the contractor part is a big part. And I know I've already touched on it, but it's really about getting people out of their, you know, out of their comfort zone with doing same way every day. Is, you know what, we know ductless heat pumps are going to help us in a lot of different ways, whether we want to introduce cooling, whether we want to have backup heat and cooling, whether we want to retrofit or we want to build that way. We do need more. The most important thing in the industry is we do need contractors. And you know what, that's part the government and part the manufacturer's responsibility to really get out there and be able to provide that training and awareness. Like Greg said, you know, during COVID, it's one of those things where we haven't been able to get people into our training center, but when we were able to sort of put it online and kind of cast from our training center, that hour and a half made a big impression on Greg's staff. But That's what we need to do with contractors. That's been kind of put on a hold, except maybe it's more virtual than it is, in person, but the in-person really helps because you got that kind of hands-on learning. But contractor awareness, contractor training is something that our industry, we lack it. And it's one of our main goals and one of my main goals for our Panasonic dealer network, and whoever wants to join that dealer network, is really to give them the tools and the education to go in and to be able to retrofit, to build, to, at any time on a whim, we want to install a mini split heat pump. Well, here's how we can do it, and we'll do it properly, and we'll get you up and running. So that's our responsibility. So stay tuned for some of that stuff that I told you about. The Panasonic Breathe Well program will incorporate a lot of those solutions and that training and awareness to really help a contractor, help a builder developer, and then in turn help the homeowner at the end really have a safe, healthy, and a smart space.
Perfect. I do realize 1 o'clock is a hard stop, but I do have 3 more questions. Let's see if we can get to that. If not, our speakers will answer the questions later after the session. So one question is, if you want to install a gas stove in a home, how will you get gas if gas will not be a supply anymore?
That's similar to the auto industry right now. Seamus O'Regan made an announcement a little while ago that you won't be able to buy a gas automobile in Canada after 2035. I don't think we are going to go near that long before gas is not allowed to go into new homes. So we're just trying to get out in front of it. In our Newfoundland homes, we don't have gas. So if someone wants a gas supply, it's propane, and it's just on the house. I personally really like cooking on a gas stove. I just know those days are numbered. So my current house that I'm building now has got an induction stove rather than gas. So I'm unfortunately going to do without my gas stove because I can see it coming.
Okay, great. Second last question. Each indoor head requires its own condensate drain. Do you drain them into the building sewer system or a dedicated condensate system?
They basically go into the sewer system. We do link some of them together and then drain it once in. It really depends on the design of the house.
Okay. What are critical design issue that you had to address to implement for this project?
The critical design issues are more on the existing system. Once we went with the Panasonic setup, it actually took more things off our critical plate. We had less things to deal with. And issues in our existing plumbing system or existing electrical system, we didn't increase any of that. More what we had to deal with is the public perception on electricity is going to be way too expensive. So it's more on our sales side. So right now with the pilot and getting some real world data, we hope to really be able to help with that. And that's why I'm really happy that Sonny and team came on board with me. That's making that a whole lot easier, where it's not just me as a little small builder and using my ability to gather data. It's theirs, and they're really stepping up to the plate to make sure that this has been a good experience and helped me through the technical switch over. So I haven't really had a lot of issues on a new system, more on the old one.
Okay, great. Thank you, Greg. So this ends our presentation for today. I hope our members found this informative. If you have any questions, please feel free to reach out to HRAI or our speakers. Additionally, please complete the evaluation survey that will appear on your screen at the end of the webinar. And with that, have a great afternoon, everyone. And thanks again, Sonny and Greg.
Thank you.
Welcome.
Take care. Bye.
Bye.